Vocal acoustic analysis: collection, analysis, and discussion on spectral data generated from vocal tissue with the larynx in the two different positions. Hi everyone, I'm Régis de Carvalho, a student of the postgraduate program at the State University of Minas Gerais. I'm here presenting this article as a conclusion work of the discipline Collecting, Analysis, and Multimedia Registration, submitted to the master course of the graduate program in arts of the University of the State of Minas Gerais, under the guidance of Professor Dr. Luiz Navida. My theme is the relationship between the position of the larynx in the neck and the sound result generated. It's very common that the discourse on the practices that involve the act of singing are based on terms more related to the sensory aspect than properly to the physiological aspect, perhaps because of the difficulty in concretely measuring each action, since the voice is an internal instrument and therefore invisible. Bringing the discussion to the theme of this work, that is the relation of the position of the larynx in the neck of the singer with the sound result emitted, it is noticed that once again the sensory aspect is one more approached in the literature that deals with the subject. Miller 2008, page 103 to 106, quotes the relationship of laryngeal position of the chiaroscuro. The author used a sensory narrative to describe the sound, saying that a larynx high in the neck would favor the excess of acute harmonics, chiaro or clear sounds, while a very lowered larynx would favor a sound with severe harmonics, scuro or dark sounds. Similarly, as previously mentioned, Campbell's 2007 connects dark and velvety sounds with a low larynx in the neck, and clear and bright sounds with a larynx high in the neck. Basic questions of research. Are there significant differences in acoustic analysis data when comparing a vocal emission with a lowered larynx with a vocal emission with a larynx at the high of the spoken voice? General objective: to understand the relation between the position of the larynx in the neck of the singer and the final sound emitted, measuring defined acoustic parameters. Specific objective: to record in audio two vocal emissions of the same vocalize, the first with a larynx in a position below the usual position of the speech, and the second one with the larynx in the position of the speech. 2. Acoustic analysis of the collected data. 3. Discuss the results of acoustic analysis. Methodological procedures. Recording of audios. The recording was made in a closed room of the School of Music of the State University of Minas Gerais on November 9, 2016. The room does not have acoustic treatment, but allows a satisfactory external noise level. Two audios with a male voice were recorded, executing with the vowel E and arpeggio of the F major chord, F2, A2, C3. In the first audio, the singer emitted the sound with the larynx positioned at a high near the position of the speech. In the second audio, the singer was asked to lower his larynx in a gesture similar to yawning and then sing the arpeggio. The arpeggio playing was 4 seconds in both versions. The tempo was marked by metronome. The measure chosen was 4 by 4. The note F2 and L2 lasted the time of a quarter, while the note C3 lasted the time of a minima, as example above. The distance from the singer to the microphone was 1 meter. The microphone used was the mark AKG Model C 414B XL2. Data processing. In order to process the collected data, the PRAT software was used. PRAT is a free software for acoustic analysis widely used by voice professionals, mainly by speech therapists. Data on the pitch, formants, intensity, and vocal spectra of each of the recorded audios were extracted. Next, a parallel was drawn between the results obtained for each item mentioned above and discussed the results. This is the audios. The first one with the larynx in a normal position. The next one is the audio with the larynx in the lower position. Analyze parameters. Sound wave. It is a longitudinal compression rarefaction wave that is able to produce auditory sensation. This is an example of sound wave with larynx in a normal position. And this one is a sample of the sound wave with larynx in lower position. Spectrogram. They are graphs that dynamically analyze the energy spectral density. The values are indicated in the time plane versus frequency. This is a sample of audio spectrogram with larynx in a normal position. And this is a sample of the audio spectrogram with larynx in a lower position. Pitch or frequency. It is related to the sound height and it is measured in hertz. Audio pitch with a larynx in a normal position is this graph. And this is a sample of audio pitch with larynx in lower position. Intensity. The classification of sound as strong or weak is related to the level of sound intensity, and this intensity is measured in decibels. This is a sample of intensity in audio with larynx in normal position. And this is a sample of intensity in audio with larynx in lower position. Formants. These are specific points of the vocal tract in which the fundamental frequency of the singer is reinforced. This is a sample with the formants of audio with larynx in normal position. And this is a sample of the formants of audio with larynx in a lower position. Jitter. It deals with the variability of the fundamental frequency considered by as a measure of disturbance of the sound height. The voice report with larynx in normal position was 1%, and the voice report with larynx in lower position was 0.47%. Shimmer. It deals with the variability of intensity, that is, it is a measure of disturbance of the amplitude of the sound wave. The voice report with larynx norm in a normal position was 12%, and voice report with larynx in a lowered position was 7.4%. Discussion of the data. The article searched through an experiment to verify if it is possible to point out some differences in the data collected in an acoustic analysis in which a male voice sings the same melody with the larynx in two different positions, normal and lowered. In order to facilitate the description of the results, it will be described as PL, the audio with the larynx in the lowered position, and it will be described as PN, the audio with the larynx in a normal position. It was possible to perceive variations between the two audios in the analyzed parameters: sound waves, spectrogram, pitch, intensity, formants, jitter, and shimmer. Although the intention was not to analyze deeply the parameters above, as well as to indicate a emission of another as connected from the results, it was possible to comment on some specific data. The sound wave chart shows difference of amplitude and uniformity between the audios. The PL audio generates wider and more uniform sound waves than the PN audio. Analyzing the spectrogram of the two audios, it is concluded that both PL and PN audio generated a spectrogram that shows well-distributed energy concentration among the formants. In the frequency parameter, Pn generated a constant wave between the sung notes. Already the PL audio presented several small oscillations between each note. It should be noted that between the note F2 and the note A2 in the audio PL, the frequency suffered a sudden drop, almost reaching zero, or an interruption in phonation. In the intensity parameter, there was little oscillation between one note and another in two audios, except for the emission of note C3 in the audio PL, in which the intensity curve increases considerably. When analyzing the formants, it is noticed that in the audio PL, the formants 1, 2, and 3 are well defined, with formants 4 less defined. NPN audio presented format 1 and 4 well defined, and formats 2 and 3 with lower definition. The jitter parameter in the two audios did not present a considerable discrepancy. The PL shimmer has a higher disturbance rate than the PN. Conclusion. It is concluded in this article that vocal emission with larynx in normal position in the collected audio generates acoustic data different from vocal emission with lower larynx. Of the acoustic parameters analyzed, the ones with the most significant differences were sound waves, formants, and frequency. The analysis of these differences, as well as the impact on singer sounds results, are themes for future work, but the results found reinforce Miller's 2008 and Campbell's 2007 view that position of larynx directly influences the sound emitted by the singers. This is my references. Well, it was a pleasure to attend this Congress. For questions, follow my email contact. Success to all!